All right, so this video will focus on Chapter 4, Section 3. And if we look here, we have to first of all find the value of x. And these are all proportional, so 1 times 6, and so 2 times 6 is 12. 4 times 6 is 24. 3 times 6 is 18. We just keep on going through. So press pause and try to figure out the value of x. All right, so the essential question is, how can you describe the graph when of the equation y equals mx? Now, just so you know, the equation of any line is y equals mx plus b, where y is the y term, of course, x is the x term, m is the slope, and then b is your starting point. So where it starts on the y-axis. And if you look here, it's missing a starting point, which means it starts at 0. And that's really an important part for what we're talking about today, because all of the graphs, when we talk about this direct variation or being proportional, have to run through the origin. Their starting point is right at the origin here. So one of their points has to go through here, or it is not direct variation or proportional. Let's give an example here. So if I look at these right here, are these proportional? And if I look here, this one goes through the origin, and it goes up at a constant rate, so this is proportional. This one, although it goes down at a steady rate or a slope, it does not go through the origin, therefore it is not proportional. This one here, if you look at it, it goes up by a constant rate or by a slope, but again, it doesn't go through the point of origin, so it is not proportional. This one does go by a steady rate and it goes through the point of origin, so it is. Let's look at these tables and find out what these are. So if we think about the table, what is it going up by every time? So if I look between these two, my rate of change is 1 here. This is 1, so this is all looking good so far. And then down here, this is going up by 110. This here is going up by 125. And this is going up by something different. But the point is, they are not the same. The slope is not the same, so therefore it is not proportional. This one here, if I look at it, every time it goes up by 1, this is going up by 1/2. So to get to 0 cups, that would be 0. I would then have 0. So I'd go down 1 on each side, right? And that would go through the point of origin. And it's a constant rate, so this one is proportional because it will go through the point of origin. Tell whether these are proportional. So again, this one here, if I look at it, this is not going through the origin, so it is not. This one does go through the origin, so it is proportional. This one here, if I look at it, it's going up by 4, then 4, then 4. This is going 2, 2, 2, so it's definitely linear. If I go back by another 4, I'll be at 0. And this will go back by 2, so it'll be 0, 0, which is the point of origin, so it totally works. This one here is going up by 3 every time, right? Well, 3 here, and then 2, and then 3. Because there's this 2 here, it is not linear. So this is a no, this is a yes, this is a yes, and this will be a no. So the key idea is direct variation. And direct variation basically means this, that the graph is y equals mx, that it will be constant proportionality, and then it runs through the origin. Those are the major things that you have to have. Again, it's got to go through 0, 0. So the starting point is 0. It's got to be linear. Right? Those are the two real main things for direct variation. So it says here the cost in y for x gigabytes of data on the internet plan is represented by y equals 10x. Graph the equation and intercept the slope. I'm sorry, interpret the slope. My bad. So if I look here, this is direct variation because it's y equals, and it's 10x, so it's 10 over 1 x. So if I look here, that means that for every x gigabit of data, it costs $10, let's say. So if I get, let's say, 1 gig, it'd be 1 times 10, which is $10. For 2 gigs, it would be 2 times 10, which is 20. And so it's a direct variation. It is proportional. Totally works. This one here, it says that All right, so for this situation, I have to actually write in a little equation. And the equation is, I have 105 times m equals 15. And when I do that, I want to actually get m by itself, right? So I'm going to go through, and I'm going to multiply this by 1 over 105 on both sides, 1 over 105. And if I cross cancel here, I can figure out how many 15s go into 105. And what I'll get is I'll get m equals 1 over 7. And that's the actual answer here. So y equals 1, 7, m. So whatever weight I put on for Earth, I'll figure out the weight on Titan. So it says, imagine that a chunk of ice weighs 3.5s on Titan. How much would it weigh on Earth? Well, it's going to weigh 7 times more, won't it? So I'm actually going to go through, and I'll take, I'll put in 3.5 equals 1 over 7m. I want to get the m by itself, so I'll say times 7 over 1 and times 7 over 1. In this case, m equals 21, 3.5, 24.5. All right, so now try represented, this cost is represented by y equals 12x. So what does the equation, or graph the equation and interpret the slope? So the slope is 12 over 1. And if I go up, it's going to start at 0 and go up 12 and over 1, up 12 over 1. So here it is, it goes up 12 over 1, up 12 over 1, up 12 over 1, and so on. In example 2, how much would a spacecraft that weighs 3,500 kilograms on Earth weigh on Titan? So for this one, I'm going to use the same formula that I had before, and I'm going to take 1/7 times 3,500, and then I'll figure out what it weighs on Titan. So if I multiply this out and divide, I should get 500, like it says here. So if it weighs 3,500 pounds on Earth, it will weigh 500 pounds on Titan. And I just plugged that into the equation here, is all that I did. For the next one, it says the distance in meters for a 4-person ski lift travels in x seconds is represented by this equation. The graph shows the distance that a 2-person ski lift travels. Which ski lift is faster? So let's basically go through and figure out what this slope is. That will help us out a lot. So I go through here and I do 2 over 4 and 6 over 12. This right here is going up by 8, and this is going up by 4. And this, of course, is my x and my y, so it would be 8 over 4, which equals 2 over 1. So this one is going up 2 over 1. For every 2 up, it goes over 1. This one goes up 2.5 and goes over 1. So this 2.5 one would actually be faster, I would think. And then graph the equation, and here it is. So you're going to see that's a steeper line that I have here. And then finally this one here, and it says compare the speed of the ski lifts in example 3. So if I look here, this is going up by 1 every time, and this is going up by 2 and 1/4 every time. So it is proportional because it'll be 0 and 0. And it's asking now, is this going to be faster or slower than the ones that I had before? So my slope is going up by 2.25. So this is going to be right in the middle between the other two. The 2.5 will be faster. This will be faster than the 2-person's one. So this is, so here it is. It'll be faster than the 2-person, but slower than the 4-person. And that's the